So students, now we move to the last section of as far as this NumPy is concerned, and this is where we are going to see the mathematical operations. If you remember, I had in the beginning of this session, I have shown you uh, what exactly is written in Wikipedia about the uh, NumPy, right? So it's a Python library which allows you to create multidimensional arrays and matrices, and it comes with tons of mathematical operations. When it comes to doing data analysis or machine learning or developing machine learning or deep learning models, these mathematical functionalities are very important so that the programmer can focus on the business logic rather than the low level implementation. So I'm going to highlight some of these mathematical uh, functions here. Let's say I have and this is where you will find that it is completely different from the list. I mean, already I have shown you their structure. So as far as uh, a list equals to, let's say, 1 comma 2 comma 3 comma 5. Now in this case there are just 5 values, right? What if there are 5,000 values, and to each of the value you want to add one? So this is just a simple one hypothetical example I'm considering. There could have been even a complex operations. So in that case, how you will write the code? Can you help me with the code if I want to add value of 1 to each of the elements from this list? Well, one approach would have been LST of 0 equals to this could be one approach. So I'm getting proceeding on similar lines. I can write code lines LST of 1 equals to LST of 1 plus 1. So in this way, I can go on writing the code. I mean, this is fine if the values inside your list are limited, right? What if you have thousands of values in your list? In that case, you will this when this approach is not advisable. In that case, what you can do is you can write code like this. Maybe you have already studied the for loop in your previous session. So I will write for I in range len of LST, okay, and LST of I equals to LST of I plus 1. I believe that this much code will accomplish what I was expecting to do. Let me just reevaluate the code for I in range. ठीक है. So Good. Yeah, it looks perfect. Let me print the output. So you can see that earlier our list contained 1, 2, 3, 4, 5. Now one is added to each of the list member. This is not a big deal, right? But when it comes to list, still you have to write this much code. Suppose if I have a similar data in my numpy array, let's say a equals to, first of all, since I have opened a new notebook, I will have to import the numpy. So let me first import the numpy as np, and then np dot array. So we are done with the creation of array. And if I want to perform the addition, done. So you can see that just just by writing a plus 1, a typical arithmetic notation which we write in Python, I'm able to add 1 to each of the array element in my numpy. So that is the very first step of mathematical operations that can be performed. Proceeding on similar lines, I can also write a into 10. Now, if we check the value of a, it is still it still remain unchanged. Why? Because here I'm just doing the calculations and printing them, right? I'm not modifying the contents of a. If you want to modify the contents of a, in that case you will have to write something like this: a equals to a into 10. Only in this case you can see that the contents of a have been modified. So all basic arithmetic operations can be applied here. Now let me take you through some of the mathematical functions which are readily available in NumPy. So I have discussed about the some arithmetic direct operations that you can perform, right? Apart from that, let's say I have a two-dimensional matrix now. Uh, a equals to np dot array oh sorry so I prefer this notation because uh, because of this I get an idea that how my 2D array looks like, right? So this is my 2D array a. Now let's say I want to perform the uh, different types of basic arithmetic operations on this array element itself. So let's say I want to uh, np dot prod a axis equals to 1. So if you remember, axis equals to 1 means perform the operation along the rows. So you can see that this product of array A will be taken along the rows. So multiplication of all this value comes out to be 16. Multiplication of this 4 times comes out to be 81. Now if I choose the same thing, okay, and change this axis to 0, so this means that perform this multiplication or do the product operation along the column. So in that case 2 by 3, that multiplication will happen and you will get product of each of the column. Now since in our case I have same values here, so the output comes out to be same. In each column we have the same value 2 3 2 3 and all that. Similarly we can also have the sum function. Instead of pod you can sum. So this is the sum along the columns, and along the rows it will be like this. Since there are only 2 rows. Now after these basic arithmetic operations, let me focus on some trigonometric functions that can be implemented with the help of numpy array. So for this, let me create another array, angles, ang angles, equals to np dot array, and let's put values like angle 0, 30, 45, then 90. So this is my array called angles. And let's say I want to find out some trigonometric I want to apply some trigonometric functions to these values, right? So in that case I can write np dot sine, np dot sin sine function, then pass a. So that will give you the sine values. Sorry, you can pass any array, doesn't matter. Of a we have got values like 2 2 3 3, right? So giving me the sine value of all those values. But since we are aware of the trigonometric function values with respect to these angle values, right, 30 45 and 90. Now here sine of 0 is 0, that I remember. Sine of 90 is 1, but in this case I'm not getting this value of 1, right? So it is because these values are these angle values by default, they are in the form of degrees, and we will have to convert them into radian. So how we can convert them? Well, for that there is a function called, again, a numpy based function, np dot deg to rad. So it will convert these values within angles into radians, and whatever values we will get, they will be passed as argument to this sine function. And now we can see that I will get the appropriate values. So sine 90 is 1, you can see that. Sine 90 is 1. Sine of 0 is 0. Sine of 30 is half, that is 1 by 2. Now there is a cos function, then there is a tan function also, and rest of the value you can calculate by taking the reciprocal of these values, because as you might be aware of the fact that cot is nothing but reciprocal of tan and so on. Then there are some hyperbolic trigonometric functions also, right? Cos h, sin h. So all you have to do is just add h in this code. So I will just write h, and you will get the sine hyperbolic function values or the values mentioned in your angles array. So we are done with the trigonometry function. Let's focus on the exponent and logarithmic function. So I hope you know exponent function, that e to the power x, right? So we do have that functionality available in NumPy, and that function is written like np dot exp. All you have to type is just the value to find the value of e to the power 1. This is the value of e to the power 1. In many mathematical calculation, one expression is always written e to the power x minus 1. Fine. So if you want to calculate that value, so there is again a ready-made function available for the same exp. It goes like m1. So you can see that the output is same, only one is subtracted from this value, which comes out. If you go into the machine learning programming, okay, let's see if I can so if you go into the machine learning programming, there is something called as logistic regression. The formula is like something like this. So this term is quite commonly used in some mathematical operations, right? So the whatever I have written the code, it basically computes this particular value. Okay, so that was about the exponent function. Now let's talk about the logarithmic function. So we have got different log functions, such as natural logarithm, then log to the base 2, log to the base 10, and so on. So functions like let's say np dot log of 1. So it is always going to be 0, I guess. Yes. For the value of 10, it will be this, right? And if you have if you want to use a different log base, then in that case all you have to type is just the name of that base, that is log 2. Then we have log to the base 10, oh sorry, etc. Well, when it comes to linear algebraic some equation, let's take the example of matrices. If you want to calculate the uh, matrix calculation, right? So if you have already written the code in C or Java to calculate the multiplication of two matrices, you might be remembering how difficult it was, right? There are, I guess, 3 nested loops which are required to perform the calculation part. Apart from that, you also have to write the code to insert the value to display the final result and all that. So you can see that in NumPy how that complex business logic can be reduced to just a single line of code, and there you have to just write down the name of the function and that's it. So let me write the code first. Let me first create the arrays a and b. By the way, do you remember what is the prerequisite for multiplication of two matrices? What is the condition if you want to perform the uh, multiplication of two arrays or two matrices? Yes. So this is my array A, Okay, and then I'm going to create array b. Let's say b equals to np dot np dot full full. And here you have to be careful because uh, by 2. So the number of columns of the first matrix rows in the second matrix. That is the, yeah. But good. So be careful while constructing this array. You want to perform the matrix multiplication. You can see that mat well, that is matrix multiplication, and just pass those two arrays a and b, and done. So this is the beauty of numpy array. Earlier, uh, in the last weekend, you have studied the basic constructs in Python, right? And maybe based on those, you can develop your own logic by implementing some small code snippets. But now going forward, what you see is that there are many some this kind of ready-made packages which comes with tons of functionalities, and you don't have, I mean, if you want to implement if you want to solve a problem, if you want to develop a solution, it could be related to data analytics, data science, or machine learning. You can see that by using such ready-made packages, you don't have to worry about the low level implementation, right? You don't have to write everything from the scratch. So just make use of these functions, and things will become very easy for you, right? So that is why we have included these packages in our syllabus. I hope you also remember the topic of determinant, right? It used to be represented something like this. Let me show you. It used to be written like this. So, yeah. Oh, sorry. Straight line like this, right? And then within these lines you have, okay, let me just show you the image, right, rather than drawing it here. Determinant. So that is how we calculate the determinant in mathematics, right? If you have, it is equals to multiplication, a diagonal multiplication will happen, and will subtract these products. So actually use this notation in most cases, right? Deter of a is with this notation. Now simply we can also find the determinant in numpy. So for example, let's say I want to create a matrix X. uh, np dot identity, let's say 5. Let's keep it 3. So this is X, and then now np dot dt, I guess, is the name of the function. Okay, it's not dt. Let me check that function name. Okay, it is not accessible directly under this numpy package. Within numpy you have another package called uh, lin alg, that stands for linear algebra dot det. So in this case you will get the determinant of this particular array equals to 1. Okay, now we are left with some handful uh, code. Some of them are very basic, like performing the sum, then reshape. So let me quickly calculate them. Do we have array A? Let me check the content of A. Okay, it's not there. So okay. Let me create array A. Array A. Okay, I want to create array A whose dimension will be 3 cross 3, and I want to initialize the value in the range of, let's say, 20, 10 to 30. Can you help me with that code? Do you remember the function that can be used to get such kind of output? You remember random package? Within that random, we had a rand int function. Now, at least tell me what kind of values I can pass here. Okay, here is the suggestion: low, high, none. So the first parameter will be the okay. Let me check. First parameter will be the 10, let's say 30, comma, followed by the shape. In this case, I'm saying 3 by 3. Anything else? I think that's it. Data type I can mention, but at the moment I won't write it. Yeah. Uh, Now, dear students, it may happen that I've been teaching you lots of functions in NumPy. In the later part of today's session, we will see some functionalities in pandas, and you will find that at the end of this course you have learned hundreds of such functions. How to remember those functions, how to remember the parameters that are used in these functions. Now, it is not possible to remember all these things by heart, right? But what I want you I mean, if you practice a lot of time, then sure, you might be able to remember them. But even in that case, now, as I've been using this since last 10 years, right? But sometimes it happens that I may not be able to recall the name of the function, or what type of parameters are required to pass to that particular function. In that case, you can definitely search on any search engine, or you should know the theory behind it. I mean, if you know that there is a function which will allow you to create a array of your choice for given values of range and for given values of their order, rows and columns, right? So that try to remember these functionalities, right? Even if you forget this function name, that is perfectly okay, because we, being human being, we are not computer machine, right? We cannot store each and every information. But if you remember such kind of functionalities, then you can always google, if you don't able to recall the name of the function or its secret, that is perfectly okay. So don't get overwhelmed with the amount of code that we have been writing on a daily basis. Okay, so my task was to perform the addition, right? So I can write a dot main. So it will give me the smallest value from this array. Similarly, we have got a dot max, then a dot mean, that is the average value, then a dot std, that is standard deviation, a dot var, which is variance. So you can see that many standard formulas are readily available in NumPy, and you can use these functions to calculate the things. Let's say, I mean, here in this case, we have calculated the mean, max, and sum also, right? A dot sum. I forgot. A dot sum. So it will perform the sum of all the values within that array. But if you want to perform these operations along maybe particular row or call along row or column, in that case I will write a dot sum, and then I can pass not this one. I will have to write np dot sum. I'm going to pass a and then axis. I think this is something we have already discussed. So it is giving you the uh, addition of your array A. This is your array A, right? Along rows, since there are 3 rows. So addition of this one, addition of these 3 values, and finally these 3 values. Here is your output. If I make it 0, it will perform the sum column wise. Similarly, you can find out the minimum value, maximum value along the column or along the rows, right? Uh, Last function that I would like to discuss here is a reshape function, which is very important function. Let's say we have got, this is 3 by 3, right? Okay, let me copy this code. Let me create 4 by 2. So this is an array having dimension 4 by 2. The total number of values here are 8, right? Let's say you want to rearrange this array. So that is possible. All you have to do is a equals to a dot reshape let's make it 2 by 4. So now you can see that we have reshape. Reshape means changing the number of rows and columns, but making sure that all the values of the original array are preserved, right? So in total we have 8 values. So it doesn't matter how you are reshaping your array, make sure that all those 8 values are there. So if I write something like this, let's say 3 by 4. So in total there will be 12 values now, right? But we have got only 8. So that is why it is showing me an error. So you can use any possible combination that will give you the output of 8. So I can write 1 by 8. That is also possible. So this is a 2D array, right? Which contains only one row, and within that one row we have got 8 values. That hence the shape is 1 by 8, or I can write 8 by 1. So there will be 8 arrays. Each array will consist of one value. So with this, we come to the end of NumPy. If you have any questions, please let me know.
So next 5 minutes for doubt clearing session. If you have any queries, please ask before go to next topic.
Yes, there is a line, there is a function called this one. See, there are